In this video, we will see an example of computing the probability of the union of mutually exclusive events and independent events. Let M and N be two events such that probability of M is equal to 0.60 and probability of N is equal to 0.21. Determine the probability of union of M and N given that M and N are independent. And then we need to determine the probability of union of M and N given that both events are mutually exclusive. To find the answer for part A, we need to reference two properties. One property says that for two independent events, the intersection of events A and B is just the product of the probabilities of A and B. The general addition rule says that if you need to find the union of two events, you are going to add their probabilities and then subtract the intersection of the two events, the overlap, in other words, that we double counted by adding these two probabilities. We're going to use both of these properties to answer first part. Knowing that the two events M and N are independent, I apply the multiplication rule for independent events, and I'm multiplying the corresponding probabilities of M and N to find that the intersection of M and N is equal to 126 thousandths. Now that I know this number, I can use the general addition rule for two events, which says add probability of N and M together and then subtract the overlap of M and N, their intersection. So I'm just substituting the quantities, 60 hundredth plus 21 hundredth minus the overlap of 126 thousandths. This yields 684 thousandths as the result for part A. For part B, it is a bit simpler because we are told M and N this time are considered to be mutually exclusive events. For any two mutually exclusive events, the probability of M union N is equal to the sum of their corresponding probabilities, which adds up to 81 hundredths.